Okay, so today's lesson is going to be on scientific and standard notation. So scientific notation is simply a way of writing a value that is really large or really small. And the example on your note page called Scientific and Standard Notation is the KSP of silver chloride is 0.00000000016. That is an incredibly small number. And what that simply means is silver chloride is insoluble, meaning it will not dissolve in water. However, because this number is so small, this value would be very difficult to write and to work with each time we wanted to use it. So we can actually put it in scientific notation, where the scientific notation value would be 1.6 times 10 to the negative 10. So the question for today becomes, how does this value become that value? So I've rewritten it down here. So to do this, what we're going to do is we're going to look for the whole numbers 1 through 9. And you see those values start right here. So I'm going to put a decimal place in between that value. So it would essentially be 1.6. Now, my decimal place moves to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So if I go to the left, that is going to give me a negative exponent. So 1.6 times 10 to the negative 10. So let's do some additional examples. I have a value of 153,000. So I am again going to put my decimal place in between the very first whole number. So when we do a scientific notation, typically we have only one number in the ones place and everything else goes in the decimal. So if I have one number, it would be 1.53. And you want to make sure you include all values that are not zeros. Now, if there's a zero in between, for example, it was 1053, then you would include that zero. It would be 1.053. And we'll do some examples like that a little bit later on. Okay, so how am I going to get this into scientific notation? It will be times 10. Now the question becomes, what is my exponent? When I move the decimal place, 1, 2, 3, 4, 5 times, in this case, I moved the decimal place to the right. And when I move the decimal place to the right, I am going to have a positive exponent. So when I see a negative exponent, that means this decimal place moves left. If I see a positive exponent, my decimal place moves right. So number 2. Here is my first whole number, 7. So 7.82 times 10. Now my decimal place moves left 1, 2 times. Left is a negative, and how many times? 2. All right, number 3. 9 is my first whole number, so that's 9.55. Now my decimal place is moving left 1, 2, 3, 4 times. So 9.55 times 10, I move left, that is a negative 4. All right, my next example. My decimal is going to go in between the 9 and the 3, 9.38, and this will be times 10. My decimal place or moves to the right 1, 2, 3 times. The right is a positive 3. So going from standard to scientific notation, I think is pretty straightforward. Students tend to struggle the most when we are going from scientific into standard notation. So 1.8, here we go, times 10 to the negative 4. So if I have 1.8, negative means I move the decimal to the left. How many times? 4. 1, 2, 3, 4. So here's where my new decimal place is. That means I have 1, 2, 3 zeros. Now, we want to go ahead and put a 0 in front of the decimal as well as a placeholder. This way, the reader of our work knows this is meant to be a decimal and not just, if I didn't have a 0 there, not just a random mark on my paper where maybe I had just had my pencil there and I was thinking. Okay, so we're going to always put a 0 in front as a placeholder. That makes it very clear to the reader this is meant to be a decimal place. All right, 6.79 times 10 to the 5th. So 5 is a positive value, which means I'm going to move my decimal place to the right 1, 2, 3, 4, 5 times. So I have to fill in my zeros. All right, so each one of these times that I move it is a 0. So that is 6, 7, 9, 0, 0, 0. Let's do 2 more practice problems. 3.99 times 10 to the 3rd. So 3 is a positive value. My decimal is going to go right. 1, 2, 3 times. I have a 0 right there, so it is 3990. And finally, 3.729, it is a negative this time. So 3.729, this is a negative, so we're going to go left 1, 2 times. Filling in my 0, and again, a 0 in front of the decimal as a placeholder, 0.03729.